In today's video, we're going to be learning how to create curves. We're going to learn how to tween the curve. We're going to learn how to sync the tween between clients without using any network data. We're going to learn how to correctly handle content streaming. And we're also going to learn how to do a little bit of object-oriented programming by creating a class. In order to create our curves, we're going to be using float curves. Now, the way float curves work is we insert float curve keys into the float curve object, and these keys contain a time, value, and interpolation mode. We have three modes to pick from. We have constant, linear, and cubic, which is the default mode. One way to imagine float curve keys are like points in a graph. So we can see a float curve key takes in two values, time and value. Now, if we imagine a graph where time is along the bottom and the value is along the side. So for instance, we can make a key with a time set to 5 and a value set to 3, which would create a point over here. And we could create a different key with a time of 8 and a value of 1. And we could create a different key with a time of 12 and a value of 5. And now we can use the get value at time at any time we like, and it will interpolate using these points to receive a value. And the value will look something like this. Okay, so now let's experiment with float curves. I've created a baseplate project, and what I'm going to do is create a local script inside of replicated first. And the first thing I'm going to do inside of this script is create the float curve. To create a float curve, all we need to do is say local float curve equals instance.new float curve. The next thing I want to do is create a float curve key. To do this, I'm going to say local float curve key 1 equals float curve key.new, and the first value is the time. I'm going to set the time to 10, and then the second value is the value. So I'm going to also set this to 10, and the third value is the interpolation mode. So I'm going to say enum.key interpolation mode, and we have three options: constant, linear, and cubic. Now, if we leave the last value empty, it's going to default to cubic, so we don't actually have to set it to cubic. So we can just set it like this. And so that we have more than one point in our graph, I'm going to copy and paste this float key 4 times and change the name to 1, 2, and 3, and 4. And I'm going to set the time from 10 to 45 to 60. And the final time is going to be 80. And I'm going to set the values from 10 to go up to 50, and then down to 30, and then back up to 40. Now we must insert these keys into the float curve. So to do this, there are two ways. One way is to say float curve, insert key, and to pass the key into this function, and we could do this for all 4 keys like so. Another option to insert keys is to use the set keys function. So if I say float curve set keys, now this requires a table of keys. So what I'm going to do is create a new table, and I'm going to call it float curve keys, like so, and I'm going to place these keys into the table like this. And now I can insert this table into this set keys function. What I'm going to do now is loop using a for loop to loop through time, and then use the float curve to receive a value, and then I'm going to create a part, and I'm going to use that value as the height of the part. So to do this, I'm going to say for float time equals 1 to 200, I'm going to create a part. I'm going to set the part's position, and I'm going to set the x-axis to float time. And for the y-axis, I'm going to use the getValueAtTime with the float time. And for the z-axis, I'm just going to use a fixed value of -20. I'm going to anchor the part. I'm going to set the part size to 1. I'm going to set the part shape to a ball, and I'm going to parent the part to workspace. So that we can see where the FloatCurve keys are, what I'm going to do is if the float time is equal to 10, 45, 60 or 80, I'm going to set the part's color to green. So to do this, over here I'm going to say if float time equals 10 or 45 or 60 or 80, part color equals green. And if we now test the game, we can see that there are 200 parts, and at the time of 10, the part should be a height of 10, and then it's going to curve up. And once we get to the time of 45, it's going to have the height of 50. And then at the time of 60, we're going to have the height of 30. And then once we get to the time of 80, it's going to have the height of 40. And all these parts over here should have a height of 40. Let's now take a look at the two other properties for FloatCurve keys. So there are two more properties called right tangent and left tangent. And the tangent to a curve is simply the angle at which the curve goes through a point. So here we can see the angle indicated by this red line. Now, if we don't set the left or right tangent for the key, Roblox will automatically calculate the tangent for us. So here we can see that Roblox has calculated a tangent for this key, roughly like this, and for this key, something that looks something like this, and for this key, something that looks like this, and for this key, something that looks like this. Let's now set a custom tangent for this third point with an angle of 45 degrees. So it's going to go through the point like this. So now, instead of the curve going down like this, it should come down and through the point at a 45 degrees and then up through here like so. Okay, so what I'm going to do now is I'm going to copy and paste all this code down here so that we have two curves. And then I'm going to move this top one further back to -30. And for this second curve, I'm going to set the third key to have a tangent of 40. So what I'm going to say is FloatCurve keys. I'm going to get the third index. I'm going to say dot. Now we can set the left or right tangent. If we set only one of the tangents, then both tangents will be set. And later on, I'll show you what happens if we set both of the tangents. So let's for now just set the left tangent. Now this value has to be in radii. So I'm going to use math.rad and I'm going to set it to 45 degrees. And if we now test the game again, we should see two curves, the top one being at the back and the bottom curve being at the front. And if we look at the third point of these two curves, we can see that if we overlap them, we can see that the back curve goes down through the point set by Roblox, and this one over here, which we set to 45 degrees, comes down and back through the point in a 45 degree angle, like this purple line that we set here. Okay, so let's now set the right tangent of the third point. So just like we set the left, I'm now going to set the right tangent, but instead of setting it to 45 degrees, I'm going to set it to -45 degrees. And if we now test the game again, we can see that the left side wants to go through the point at 45 degrees, where the right side wants to go through the part at -45 degrees, which creates a point like this. Okay, so now that we've learned how float curves work, let's delete this local script and let's now create a path and tween parts between each point in the path. So the first thing I'm going to do is inside of Workspace, I'm going to create a new folder and I'm going to name this folder Paths. And inside of this Paths folder, I'm going to create a model. And inside of this model, I'm going to create a part. And what I'm going to do with this part is I'm going to set it to a green color. I'm going to set the size to 333. I'm going to set can collide to false, can query to false, can touch to false, and I'm going to set anchored to true. And I'm also going to set shape to ball. And now I'm going to move this ball slightly forward and up. And then I'm going to press Ctrl D to duplicate this ball. And I'm going to move it over here. I'm going to press Ctrl D once again and move this one over here. And then I'm going to press Ctrl D one final time and move this one over here. And then I'm going to name this ball 01, 02, 03, and 04. Let's now create the part that's going to tween from point to point to point. So inside of Workspace, I'm going to create a new part. And for this part, I'm going to set the material to neon. And then I'm going to set the size to 222. I'm going to set can collide, can query, and can touch to false. I'm going to set anchored to true. And I'm going to set shape to ball. The next thing I'm going to do is inside of this part, I'm going to create an attachment. And I'm going to set the position of this attachment to 0, 1, 0. And then I'm going to create another attachment. And I'm going to set this other attachment to a position of 0, -1, 0. So one attachment's going to be at the top and the other attachment's going to be at the bottom. And now inside of the part, I'm going to create a trail. And for this trail, I'm going to set face camera to true. I'm going to set light emission to 1. I'm going to set transparency to go from 0.5 all the way up to 1. And I'm going to set attachment 0 to this top attachment and attachment 1 to this bottom attachment. And then I'm going to set lifetime to 1. And for width, I'm going to set it to go from a value of 1 all the way down to a value of 0. And if we now move the part, we should see that it has a trail. And what I'm going to do is move this part into replicated storage. Let's now create our simple path class. So inside of replicated storage, I'm going to create a module script and I'm going to name this module script path. Now, in order to make this module script act like a class, all we need to do is say module.__index equals module. And then I'm going to create a function within this module called module.new equals function. And inside of this function, we're going to create a variable called self. And I'm going to say equals to set meta table. And I'm going to create a new table. And I'm going to set the meta table to this table to module. And finally, I'm going to return the self table to whoever called the new function. Now, if you're not too sure how meta tables work, I have a video on my channel which will go into more detail into how meta tables work. But in short, what we're doing is when someone calls the new function, we're creating a new variable called self, and we're setting this variable to an empty table, and we're setting this empty table's meta table to module. And module has set its index to itself. So what this allows us to do is store shared values within each object. For instance, if I create a value inside of module to something like this, now if we try to access this value key within this table, even though this value key does not exist within this table, because we've set the meta table to this module table, it's still going to be able to find this value over here. And this is going to help us save memory. So for instance, instead of having to create a function for every object that when we call new, what we can do is share a function between all objects by simply placing the function inside of this module table. So I can create a function over here called set, and now we can access this set function using the self table. So for instance, I can say self, and I can call the set function like this. And what Lou is going to do is first going to attempt to find the set key within this table, and it's not going to be able to find it. So it's going to check the meta table, and the meta table is going to tell it to check this table, which is itself, and then it's going to check for the set key within this table, and it's going to find a function over here. Let's now delete this shared value key because we don't need it. And let's also delete this set call because we don't need that as well. But let's keep the set function because we're going to use this in the future. And now that we've created our class, let's create a script which is going to use this class. So inside of replicated first, I'm going to create a local script, and I'm going to name this script paths. And inside of this script, what I'm going to do is I'm going to require this module script. So to do this, I'm going to say local path module equals require game.replicated storage wait for child path. And then I'm going to use the module to call the new function, which is going to return the self object, which is this table over here. So to do this, I'm going to say local path equals path module dot new. And now what I want to happen is when we create a new path, I want each path to have a part with a trail within it. So to do this, what I'm going to do is I'm going to first get a reference to this part inside of replicated storage. And to do this, I'm going to say local part equals game.replicated storage wait for child part. And now that we have a reference, I'm going to clone this part and store it within the self table over here. So over here, I'm going to say self.part equals part.clone. And then I'm going to parent this clone into the workspace. So I'm going to say self.part.parent equals workspace. The next thing we're going to want to do is create 3 float curves, one for the x-axis, one for the y-axis, and one for the z-axis. So a way we can do this is to simply say self.curve equals instance.new. Now instead of using a float curve, we're going to be using a vector-free curve. A vector-free curve is simply a container for 3 float curves. And we can extract the 3 float curves from this container by simply doing local curve x, curve y, and curve z equals self.curve, and we can call the x function, the y function, and z function to extract the 3 float curves from the vector-free curve. Now, what I'm going to do is I'm going to create an array of positions, so an array of vector-frees, like this. And I'm going to create 3 random vector-frees, and I want to pass this positions variable to the new function. So I'm going to place this over here, and I'm going to receive it over here. Now I can use this array of vector-frees to calculate the curve float keys for the curve floats. So what I'm going to do is I'm going to loop through each position inside of this positions array. So to do this, I'm going to say for index position in positions do, and now I'm going to use the position to create a key and insert it into the curve X. So to do this, I'm going to say curve X insert key, and I'm going to create a new float curve key, and I'm going to use the index. Now because index is going to start at a value of 1 and I want time to start at 0, I'm going to subtract index by 1, so it starts at 0, and then I'm going to store the position X value, which is going to be this, this, and this value, into the curve X. And now I want to do the same for curve Y and curve Z. So I'm going to copy and paste this 2 times. And I'm going to change this to curve Y and this to curve Z. And I'm going to set this to position Y. So it's going to be this value, and this value. And for this one, I'm going to set position Z, which is going to be -20 for all keys. And one last thing I want to do for the new function is, before we parent the part into workspace, I want to position this part at the first position in the array. So to do this, I'm going to say self.partPosition equals positions, and I'm going to get the first index from the array. So now that we've stored a part and a curve inside of this table, let's use them 2 values inside of our set function, and we're going to use the time that we pass into this function to extract the X, Y, and Z coordinates from the 3 float curves, and then we're going to use them 3 values to set the part's position. So to do this, first I'm going to use the curve to extract the 3 numbers, X, Y, and Z coordinates. So to do this, I'm going to say local position array equals, we're going to use the curve, and we're going to use the get value from time function using the time that we pass into the set function. And then I'm going to create a vector3 from this array and set the part's position. So to do this, I'm going to say self.part.position equals vector3.new, and we're going to unpack this array. And this array has 3 numbers within it, and we're going to use them 3 numbers as the X, Y, and Z coordinates for the vector3, which is going to set the position of the part. Now, if we wanted to, instead of creating this variable, we could pass this function directly into the table unpack, like so, and this has the exact same result. Okay, so now let's create a for loop inside of this script and use the set function to constantly set the position of the part. So what I'm going to do is say for curve time equals, now if we remember, we set the time to start at 0, so we want curve time to start at 0. So this key is going to be set at 0, this key is going to be set at a time of 1, and this key is going to be set at a time of 2. So we want to go up to 2, and I'm going to increment 1 at a time. And then what I'm going to do is say path, and then I'm going to call the set function, and I'm going to set the current time. And another thing I want to do is, before we loop to the next loop, so this loop doesn't finish instantly, I'm going to use task.wait, and I'm going to wait 1 second between each set. Another thing I'm going to do is, at the top over here, I'm going to also add another task wait, and I'm going to wait for around 5 seconds so that we have enough time to enter the game to see the part moving. So if we now enter the game, we should see the part at the first position, then it moves to the second position, and finally it moves to the third position. But instead of incrementing time by 1 each time, let's increment time by 0.1 and see what happens. So now we should see that every 1 second the part increments through time by 0.1, and after 10 seconds it will reach the second point, and after another 10 seconds, it'll reach the final point. Okay, so instead of using a for loop to set the part within the path, let's now use the run service's heartbeat event to set the path. So at the top of the script, I'm going to get the run service, and then I'm going to create a loop function. So I'm going to say local function loop, and then I'm going to connect this loop function to the heartbeat event by saying run service.heartbeat connect loop. And now, instead of using this for loop, what I'm going to do is first create a new variable, and I'm going to call it curve time, and it's going to be set to 0. And inside of this loop, we're going to use delta time to increment curve time. So I'm going to say curve time plus equals delta time. And then I'm going to set the path. And now we can delete this for loop. And if we now test again, we should see that it takes 2 seconds to reach to the end of the path. One thing to take note of is the distance between these points have no effect on how long it takes to get from one point to the next. Because we're using a fixed value of 0 for this point, a time of 1 for this point, and a time of 2 for this point, it's always going to take 1 second to get from one point to the next. So even if I set this value to -100, it's still going to take 1 second to get from here to here, and then 1 second to get from here to here. So let's now change this. So instead of taking 1 second to get from one point to the next, let's use the magnitude between these two vectors to calculate the time instead of index -1. So what I'm going to do is create a new variable. I'm going to call it curve time, and it's going to start at a value of 0. And then over here, if the index is greater than 1, because I don't want to increment this on the first index, only once we get to the second index. So I'm going to say if index is greater than 1, then curve time, and I'm going to add the magnitude between the current position and the previous position. And then instead of using index -1, I'm going to use curve time. If we now test again, we should notice that instead of taking 2 seconds to complete the path, we should now be taking a lot longer to get to the end of the path. And if we zoom into the part, we should notice that it moves at roughly 1 stud per second. And that is because let's assume that the distance from the first point to the second point is 100 studs. So that means it's going to take 100 seconds to move 100 studs. And if we wanted to increase the speed of the part, we could simply multiply delta time by the speed. So for instance, if I want the part to move at 10 studs a second, I can multiply delta time by 10. And if we now test this, we should now see that the part moves 10 studs per second. But let's assume that we wanted every path to have a different speed. So by doing it this way, every path is going to need its own curve time. But let's do it a different way that doesn't require us to have a different curve time for each path. So what I'm going to do is, instead of setting delta time times 10, I'm going to set the speed when we create the path. So over here, I'm going to set the speed to 10. And then I'm going to get the speed variable over here, like so. And now all we need to do is divide the magnitude by the speed. So I'm going to say magnitude divided by speed. Let me try to explain why dividing the magnitude by the speed creates the effect that we want. So let's imagine that instead of using the value of 10, let's use the value of 2. And let's imagine that the magnitude from the first to the second point is 100 studs. So when we measure the magnitude, it's going to return 100. And then we're going to divide 100 by 2 because we set the speed to 2. So that means we're going to add 50 to the curve time. So what that means is we're going to be able to move 100 studs in 50 seconds. So that means we must be moving at 2 studs per second. And if we set this to 10, we're going to divide 100 by 10, and that's going to allow us to move at 10 studs per second. Let's now replace our free vector freeze with the positions of these green parts that we created earlier. One thing that we need to take into consideration is content streaming. So if we select workspace and look into the properties, we can see that streaming enabled is set to true. So what that means is these green parts can stream to the client at different times depending on how far away they are from the client's character. If you want more information on content streaming, I have a video on my channel called Content Streaming, which you can find here. And this video will go into more detail about content streaming. Now, because we're going to need the position of all these parts in order to create this ray at the exact same time, what we need to do is make sure that these parts stream in all together at the exact same time and not one by one based on how far away it is from the character. Now, to do this, all we need to do is select the model, and here where it says model streaming mode, we want to change this to atomic. And now this entire model will stream into the client at the exact same time. And so that it's easier to test content streaming, what I'm going to do is inside of workspace, I'm going to change streaming target radius to 128. And the next thing I'm going to change is inside of starter player, I'm going to set the character walk speed to 20. If we now test the game, and if we look inside of workspace and inside of paths, and we start to walk away from the model, we should see that the model with all the parts stream out. And when we walk back, the model should stream back in with all the parts at the exact same time. So in order to detect when a model is streamed in or streamed out, we're going to be using the child added and child removed events on the paths folder. So the first thing we're going to need to do is wait for the paths folder. So we can do this by simply saying paths folder equals workspace, wait for child, paths. And then I'm going to create a new function, and this is going to be called child added. And then I'm going to connect a event, the child added event, for this folder to this function. So to do this, I'm going to say paths folder.child added connect child added. So we connect this function to the child added event. Next, I'm going to create the child removed function. So child removed, and now let's connect the event to this function. So I'm going to say paths folder.child removed connect the child removed function. Another thing we need to take into consideration is the model may have streamed into the folder before this path script has run. So we need to loop every model inside this folder before we connect the connection for any models that already exist in the path. So to do this, all we need to do is say for index child in paths folder, and we're going to get all the children, and for each child we're going to call the child added function. So if any children already exist by the time we run this script, that's not going to get missed out, and we're still going to call the child added function for that child. And now, instead of using these vector freeze for the positions, what we're going to do is we're going to get the positions from the model when it streams in. So I'm going to move this into child added, and I'm going to remove these vector freeze. And now I'm going to loop the children of the model, which are these parts here. So to do this, I'm going to say for index child in model get children. And because the order of get children is not defined, so the order of this index value may not be the same as what we've set the names to, instead of using index as the key for the positions, we're going to use the child's name. So to do this, I'm going to say positions, and I'm going to say toNumber. So we're going to convert the name string to a number, and I'm going to say child.name equals child.position. And the next problem we have is we're creating the path using the module, and we're saving the path locally within the scope of this function, but we don't have access to this path inside of the loop. And another problem is in the future we may have more models, more paths within the paths folder, so we don't want to just save one path, we want to save many paths. So to do this, I'm going to create a table. So I'm going to say local paths, and I'm going to create an empty table, and then I'm going to place this path into this table. So to do this, I'm going to say paths, and for the key, I'm going to use the model. So I'm going to say like this, and use the model as the key. And so now all we need to do inside of the loop is loop through this table like this. And now we can access the path from within the table. And if we now test the game, we can see that after 5 seconds, the path is created and the part moves through the green parts that we created. And one thing we need to take note is here we can see the part, and if we move away from the model, so it streams out, we can see that the part stays there, but the model streams out. And when we walk back towards the model, we can see that now we have 2 parts. So this is happening because when we stream out the model, the part is not destroyed, but when the model streams back in again, the path is created a second time, which creates 2 parts. So let's now create a destroy function for the path class. To do this, I'm going to create a brand new function called destroy. And inside this function, we're going to destroy this part that we created up here. So to do this, I'm going to say self.part destroy. And at the same time, I'm also going to destroy this curve instance that we created over here. So let's say self.curve destroy. And now inside of the child removed function, we're going to use the model to access the path inside of the paths table, because remember we use the model as the key. So the first thing I'm going to do is call this destroy function, which is going to destroy these 2 instances. So let's say paths model destroy, which is going to call this function. And then I'm going to remove this path from the paths table so that it's no longer found within this loop. So I'm going to say paths model equals nil. The next thing I want to do is have the path loop back to the start once it reaches the end. So in order to do this, we're going to use the modulus operator. And if you want more information on how the modulus operator works, you can check out my video on my channel called Modulus Operator, and this will go into more detail on how this operator works. So the first thing we're going to need to do is we need to know how long it's going to take for the path to reach the end, so we know when to loop back. Now we already worked this out and we're saving it within the current time variable, but this variable is currently being discarded. So let's save this variable into self. So I'm going to replace this to self.time equals 0. And then instead of incrementing curve time, I'm going to increment the self time. And I'm also going to use self.time over here. And now we can access this variable over here. So what I'm going to do now is create a new variable over here called loop time equals, and it's going to be equal to curve time, but we're going to use the modulus operator with the time variable inside of this path object. So I'm going to say path.time, and then I'm going to replace curve time with loop time. And finally, because this path is going to be constantly moving now, we no longer need to wait 5 seconds, so we can remove this task wait. And if we now test the game, we should see that once the part gets to the last part, it loops back to the start and does it over again. The next thing I want to do is sync the movement of all the paths between all players. And currently, because we're using curve time, and curve time is set to 0 when the player enters the game, because this value is not the same on all players, the position of the paths will not be the same for all players. So what we can do is delete curve time, like so. And over here, I'm going to replace curve time with a new variable called server time. And we're going to use the GetServerTimeNow function, which will be in sync between all clients. And we can now delete this. And instead of using curve time, I'm going to replace it with server time. So that we have more than one path, I'm going to duplicate this model and I'm going to move this over here. And I'm going to adjust the points of this path to be unique from the first path we made. So to set to something like this. I'm also going to duplicate the fourth point and I'm going to rename it to 0, 5, so it gets placed in the correct key for the positions array. And I'm going to move this over here like so. If we now go to the test tab and start a local server with 2 players, what we should notice is on the server side, there is no parts moving. And if we go to view and network, we can see that the overall incoming and outgoing data is almost 0. So the parts movement have no effect on network data. And if we take a look at both clients, we can see that the parts move in sync between both clients. And if one of the clients walks away and streams out one of the models, now we can see that this client on the left is only animating one model, while this client on the right is animating 2 models. And if this client walks back into range and the model gets streamed back in, the part is back in sync between the 2 clients. Let's now use the tween service and use the getValue function to tween our paths. So the way the getValue function works is we provide a number between 0 and 1 and a ease in style and an ease in direction, and it's going to return a number back to us. For instance, if we choose the bounce ease in style, and if we passed in the alpha of 0.5, what it's going to do, it's going to go up, and where it intersects with this line, it's going to return this value. So 0.5 will return a value of roughly around 0.25. Or for instance, if we passed in the value of 0.75, if we go up, it intersects around here. So this is going to be around 0.6. So let's now create a new function for our class and let's call it tween. So over here, I'm going to create a new function called tween. And just like the set function, it's going to receive a time, but unlike the set function, it's going to receive a ease in style and a ease in direction. The first thing I'm going to do inside of this tween function is calculate the alpha. To get the alpha, all we're going to do is divide the time by the total time. And we can do this by simply saying local alpha equals curve time divided by self.time. Another way to think about alpha is like a percentage where 0 is 0% and 1 is 100%. And now let's use the getValue function inside of the tween service. So the first thing I'm going to do is get the tween service by saying local tween service equals game getService tween service. And now I'm going to use the alpha, ease in style and ease in direction to get the tween value. So to do this, I'm going to say local tween equals tween service get value. I'm going to pass in the alpha, the ease in style and the ease in direction. And now that we have the tween value, we're going to expand this out the same way we did for alpha, but in the opposite direction. So here we can see that we're converting time into a normalized value between 0 and 1, and now we need to do it in the opposite direction to expand it back to be based on the total time of the path. So to do this, I'm going to say curve time equals tween multiplied. Instead of divide, we're going to do the opposite of multiply by self.time. And now that we've calculated the tweened curve time, we're going to do the same as set. So I'm just going to copy and paste this over here like this. But if we wanted to, we can compress our code slightly by moving this directly into the function. And now I no longer need to update tween time and just pass the value directly into the getValueAtTime function. Let's now replace the set function with the tween function. So over here, I'm going to change this to tween, and we're going to use the same loop time for the curve time. Then we need to pass in the easInstall. So let's go enum.easInstall, and I'm going to use bounce. And then for the easInDirection, we're going to go enum.easInDirection, and I'm going to use out. And if we now test the game, we should see that when the part gets to the end, instead of just instantly teleporting back, it now has a bounce effect before it teleports back. And as an example, we can set the easInstall to exponential and the easInDirection to in and out. And now we should see that the part starts off slow, speeds up as it gets to the center, and then slows down once it gets to the end. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.